Alright, here's the Cliperian experiment. My name is Jadyn Rumfellow and I am Group 2 reporter. So, overview of the experiment. Our objective was to determine the latent heat of vaporization of water using the Cliperian equation over a range of temperatures and pressures. The results will be verified using the steam tables, and the data calculations found were done using the boiling beads, which helped provide a way for smoother boiling. So here's the theory. The Cliperian equation is a significant formula that relates saturation pressure and temperature to the changes in phase and its specific enthalpy. With the equation, it is important to understand that the behavior of different phases and materials. So here's the Cliperian equation right here, and it's the dp sat over dt, which is equal to the SFG over VFG, and then equal to the HFG over the TV of FG. And then you have the ideal gas equation, which is the dp sat over dt equal to the SFG over the VFG, which is equal to HFG p sat over t squared r. And then here is the apparatus. So this is the one that was in the lab manual. You can see 1 is the flask with the rubber stopper, 2 is the hot plate, 3 is the thermocouple, 4 is the pressure transducer, 5 is the pressure gauge, 6 was the air bleed valve, 7 was the vacuum control valve, 8 was the centrifugal pump, 9 was the water reservoir, and then 10 was the computer system. So then I also included this picture. It kind of helped explain it a little better. It's not as crazy as that one. So the reservoir was right here, the pump was back here, the air bleed valve was up at the top, and then you can see the flask with the thermocouple and the pressure transducer. Now here's the raw data for the pressure versus temperature graph. You can see that we calculated the values in degrees Celsius, and then the values were produced in PSIA. I converted them to KPA to help me with the steam table charts. So here was the pressure versus time graph. And you can see that the blue data is the experimental data calculated, and then the tabulated data was from the steam tables. And then here's how the data was calculated for procedure 1. HFG of T was approximated as a function of the ideal gas constant, saturated temperature and pressure, and calculating the change in pressure over the change in temperature. And it is important to note that this procedure is not very good because of the large errors associated with taking the local derivatives. And then here is that raw data for procedure 1. And you can see that degrees Celsius was used, and then the HFG of the experimental data. And here's the graph for procedure 1. So you can see the tabulated data from the steam tables is the pink, and the experimental data is at the bottom. And here's how the data was calculated for procedure 2. The HFG was calculated by obtaining an expression which closely approximates the P of T and the dP of T over the full range of temperature. And here it is important to note that the large errors produced from procedure 1 are mitigated by obtaining the appropriate expression relating the pressure and temperature. And here is the raw data for procedure 2. And on the left you can see we used the degrees Celsius, and then on the right was the calculations for procedure 2 to get that latent heat of vaporization. And this was the graph for procedure 2. Once again, the experimental data is blue, and the tabulated data from the steam tables is pink. Here's how the data was calculated for procedure 3. HFG of T was calculated by integrating the Cliperian equation for ideal gases, where C1 is equal to a constant, C2 is equal to A over R, and C3 is equal to B over R. Here it is important to note that this was similar to procedure 2, except the data analysis feature in Excel was used to calculate a more accurate graph. And so on the right you can see the data that was used for the graph, and then C1, C2, and C3 constants were produced from that data analysis in Excel, and then we have the A and the B values as well. And here is the graph for procedure 2. The experimental data is in the blue, and the pink data is the tabulated one, which is from the steam tables again. So in conclusion, for procedure 1, large errors were expected, so the calculations done for this part could produce inaccurate results. For procedure 2, it produced a better estimation of enthalpy in relation to procedure 1, and then procedure 3, the results from this procedure were the most accurate in determining the enthalpy. And here are my references.